constructed from a channel and a plate. Assume all corners are square and neglect the size of the well at A.
Okay, so how do you know we're looking for centroid?
Says it's revealed.
Okay, because they asked us for centroid. Well, we don't know if they're using the wrong terminology or not. They shouldn't, it's a textbook. But why, how do you know, same question, how do you know we're dealing with centroid? Because they're giving us area. Right? And let me just look at the picture so it reminds me what it looks like. And it could have been a 3D problem, right? But in this case, we're only looking at 2D.
Because they give us dimensions for that.
Yeah, they need to give us the dimensions for that. So where do they want to, what's the distance? In the picture, they want us to find y bar, correct? Where the centroid of this body is. So where do you want to measure everything from? I don't know, I think, well, let me see where I measured it from. I measured it from the top. So if I measured it from A, then those two plates right there would have negative values. And then also, they want me to find y bar, so I might as well just do it at the top. Otherwise, if I do it from A, I'm going to have to subtract something to find that distance. Does that make sense? Okay, so how do we, so we know we're doing centroid. Are we doing centroid of area or volume? Area, it's 2D. So what do you want to do? The idea in engineering is that we're putting a bunch of bodies together. Remember when we did distributed load problems, we separated the things into different sections and bodies? So what I did is I took this thing and I separated it into 5 sections. And you could do less, you could do whatever you want. Notice one of the things they did tell us is even though those bars, what do they call them? What's the flat things called? Flanges or plates? Plates. Even though they're bent and they're curved, they said to make it just as if it was rectangular, right? Something that we often do in engineering. We just, we're rounding answers. Okay, so you can see in my little picture up here, so section 1 represented this vertical part right here. Section 2 represented this vertical. Section 3 represented this horizontal piece. Section 4 represented this horizontal. And section 5 represented the vertical. So the first column represents the items. Okay, anybody have questions so far? What does the second column always represent? The first represents the object. The second column represents the critical component. In this case, we're doing centroid of area, so the second column represents the area. The next column represents the distance to the centroid. Yes, I'm using the right word. The distance to the centroid of that of each of those bodies. And then the last column represents the area, the critical component, times the distance. And then I summed up the areas, and I summed up the areas times the distances. By the way, I've already checked on this, and the IT, they know that there's a problem, and they're trying to fix it, so you just have to deal with it. I don't know, software or cabling, I don't know. I'm not an electrical engineer. So I sum up the areas times the distances divided by the sum of the areas, and I get the distance. And then you can even check it. I mean, look at it visually. Does it make sense that the centroid is 260 millimeters down? Let's take a look at the picture. Well, it definitely shouldn't be halfway, right? If the vertical is 350, half of the vertical would be 175, and it can't be there because there's so much area down at the bottom, so it must be lower, so it seems reasonable to me. That's how you do these problems, all of these problems. So Mark and then Andrew.
I got a question about the distances.
Yes.
In the third column.
Did I make a mistake?
No, I just don't understand how you're getting them.
How I got them?
Yeah.
Okay, so we're treating all these as rectangles, right? So item number 1, section 1 is 70 millimeters times 10, right? Because it's 70 high and 10 wide, okay? And then the centroid, we're measuring it from the top. So if you look at this problem, in order to find the centroid of that vertical piece, let's put this, can I use this for a minute? So I'm trying to find the centroid of this vertical piece.
Oh, I see it.
Right?
Yeah, I see it.
So I gotta go down 350, right? Then I gotta go down another 10. So did I go down 360? Did I
You
make
went
a
down
mistake?
you went down 70.
Oh, wait, 70, okay, sorry. I was thinking about going down another 10, but the dimension here is 70, it's the total,
Yeah.
right?
Uh-huh.
So the centroid of this piece right here is gonna be 350 plus half of 70, and it's gonna bring it right here. Got it?
Yep.
And for this big piece, oh, actually I did them separate, right? So, but that doesn't matter, it's the same. It would be 350 plus a half of 10.
Cool.
Jill? You're okay? Questions? No problem?